The SG-3 superdeep well in the Kola peninsula in Russia is the world's deepest hole into the Earth. It is now 12.3 kilometres deep, or over 40,000 feet. The three universities of Bergen, Glasgow and Wyoming offered the Russians the opportunity of doing a deep seismic survey through the well, using Western field equipment and computers. The aim of our multinational experiment is to obtain a seismic cross-section through the crust, at the one place in the world where we can test our ideas on the deep layering of the continents against the ground truth of the rock samples recovered from the well in over 20 years of drilling. You can get an idea of the scale of this Russian feat of engineering by looking at this 1 to 1,000 scale model. At that scale, a human being is just under 2 millimeters high. And as we look down under the model shelf, the 12 meters of string hanging down 4 flights in the stairwell represents to scale the 12 kilometers depth into the crust. The slinky spring hanging just to the left of the drill string gives an idea roughly to the correct timescale of the passage of seismic waves down and back up, as if they were bouncing off a layer about 12 kilometers deep. It takes 2 or 3 seconds for the shock pulse to go down and back up. The Kola Peninsula lies to the north of the Arctic Circle in what is now Russia. The well, shown by the star, is situated in the western part of the peninsula in what was formerly Finland. The British, Norwegians and Americans made their separate ways by air, sea and road through Lapland to meet at the northern Norwegian town of Kirkenes. From there we drove the 80 kilometres or so over the Russian border to the mining town of Zapolyarny, which was to become our base for the next few weeks. The new town was built in the 1950s on a hill, a kilometre or so north of the large copper-nickel mines. The hills behind the mine plant are actually spoil heaps. The smelters are unpopular with their Nordic neighbours because the prevailing wind frequently sends sulphurous pollution north and west into Norway and Finland. The problem was not so bad until the smelters started processing ore with high sulphur content, transported across the Arctic Ocean from Siberia by atomic icebreaker. We unpacked and got our gear ready at a local survey base in the town. Lee and David got to work rewiring hundreds of geophone connectors. In the former Communist Party meeting room, Lenin is looking down on 3 research students, Dima, Sergei and Igor, sent up from Moscow to help us with the fieldwork. They were keen to get their hands on the various computers that we had brought with us. Scott Smithson is the leader of the US contingent. Bob Busby from the Irish consortium was responsible for the 80 RefTech remote recording instrument. The Russians had assumed that we would use their own red and yellow sledge-mounted recording huts, which were heated by a wood-burning stove. This comfortable option proved to be impracticable, so we had to transfer our 2 seismic recording cabins, known as doghouses, onto the large sledge bases. Our vibrator trucks are not really suitable for cross-country work, so Ingvar Kristoffersen in the orange overalls, the leader of the Norwegian contingent who owns the vibrators, knew that he had a problem on his hands. Beside Ingvar is Con Gillen from Edinburgh, whose skills as a linguist proved crucial in the 3 years that it took us to plan this experiment.
What's that, Con?
I think it's fruit. It's some kind of Americans are afraid to dinner serving. Is that from the Gulf War? For hundreds of people in one box.
The first step in getting the vibrators roadworthy was to put snow chains on them. Aside from the 4 20-ton vibrator trucks, we shipped about 10 tons of equipment from Bergen, Laramie and Glasgow. The 4.5 tons of seismic cable, specially designed for Arctic use, had been donated to Glasgow University by Simon Horizon. It was in pristine condition, as it had only ever been used once before for a survey in Svalbard. It is a 120-channel cable made up of 50-metre-long sections. As luck would have it, the winter of 1992 had been unusually mild. In the Arctic, this meant that there was very thick snow cover, but that the ground itself was not very well frozen. So we knew there were going to be problems with our vibrator trucks, which are designed for road use. Meanwhile, inside the garage, the multinational team was busy making skis for the vibrators. The Norwegians, who know a few things about skiing, had gone back into Norway and returned with 4 tons of lumber. The plan was to tow the vibrators mounted on skis using Caterpillar tractor vehicles. The Glasgow and Wyoming doghouses were each mounted on one of the large sledge bases, and the Glasgow doghouse was enlarged by the construction of a rather nice wooden vestibule, although there wasn't room for the wood-fired stove. Due to the complexity of the three-component recording we were planning to employ, we couldn't use the 220 sections of cable in the normal roll-along mode. Instead, we connected up the cable into 3 fixed spreads, each of 1,500 metres in length, one for each 96-channel recording system. Consecutive take-out points were colour-coded red, white and blue for each of the 3 components, and the whole 4.5 tons of cable was spaghettied onto a huge sledge, ready to be transported to the field. The computer network for QC processing of the data while the survey was in progress was to be set up in this large hut, which immediately became known as the Green Palace. So we set off west, passing through another one of the ghastly mining towns of Western Kola. This is the town of Nickel, named of course after the metal. At the moment it seems to be sending its pollution northwards into Norway. After Nickel we drove south about 40 kilometres to arrive at the field camp, which was to be at the southern end of the 35-kilometre long profile. So for about half of the 2 months duration of the survey, we would be living in these huts at the southern end of the line. Chris Humphreys from Wyoming, on the right talking to Lee Liberty, was the chief technician in charge of the survey. And here are several of the Western Field Party trying out the local transport. The address of this particular hut seems to be number 1 Swamp Street, which apparently is what the camp is like in summer. The Russians had advised us to do the survey in the late winter, when the storms have passed and there is a reasonable amount of daylight, but when the ground is still frozen.
It's the Russian vibrator! I really don't know what it's doing here, but they drive it around a lot. I think they're just trying to prove to us that their vibrators can move in this sort of muck, where ours are having a lot of trouble.
Yeah.
What is dangerous in what is dangerous in Russia?
I think maybe the hydraulics on that tractor on the front bumper pushing down. The pivot on the pad and lift the rear end up.
They have done a lot of vibroseis surveys in this region prospecting for minerals. We had a lot of trouble simply getting our vibrators onto the specially made skis, but once they were on, things seemed to go quite well. Lee Liberty was in charge of the quality control data processing. We had a network of 2 Sun workstations, 2 PCs and various peripherals set up in the Green Palace. David Abensour from Glasgow also helped with processing and programming. We started in the south near the field camp, shooting a straight line in a north-northeasterly direction for 34 kilometres or so through the well marked by the star. The arcuate belt of rock just to the north of the well is the outcrop of the Peninsula volcanic series, which dips in a southerly direction. Here is a cross-section of the field geometry we were using. The 3 spreads were laid out in line, totalling 4.5 kilometres in length. The Wyoming doghouse was connected to the southerly spread, and the Glasgow doghouse, with its 2 recording systems, was connected to the middle and most northerly spread. The direction of progression of the survey was to the left or north. The vibrators were always off-end to the south, moving up during the day as far as the most southerly geophone. The most southerly spread was then lifted and placed in the north, and the 2 doghouses were shuttled up one position, and then the whole thing started again. The upper crustal geology in this area consists of the southerly dipping metabasalts of the Peninsula series. And if we now take a look from on top of this hill looking south and then north, we'll get an idea of the scale of the whole survey. The survey line came over these mountains in the south, and somewhere down in the valley below is the convoy of vibrators, with their caterpillar tractors pulling them. As we look over to the east, we can make out the outcrop of the southerly dipping basalts. These are classic pillow basalts, as seen in this exposure photographed during the summer. Going round to the north, we can see the Wyoming doghouse down in the dip. And there, halfway up the hillside, is the Glasgow doghouse, with the spread continuing on up north over the hill there. For most of the survey, we used 3 out of the 4 vibrators, each towed by a caterpillar tractor or bulldozer. This seems to have given us enough energy to see the moho reflection at 10 or 12 seconds of two-way time. The sweep length was 20 seconds, followed by a further 20 seconds of listening time, making 40 seconds of recording in total at a 4 millisecond sample interval. The sweep frequency band was from 10 to 60 Hz. We did 8 sweeps at each vibrator point, with a move up in most cases of 5 meters per sweep. The vibrator points were 100 meters apart. This gives us a 22-fold CDP stack with a 25 meter depth point spacing, more than adequate for good resolution of upper crustal structure. Our Russian colleagues had shown us some of their upper crustal reflection data for mineral prospecting in this region. With 24-fold stack and only one vibrator as a source, it was remarkably good. The 4.5 kilometre spread was made up of 90 stations, each of 3 components at a spacing of 50 metres. We experimented with various combinations of separate horizontal component and vertical component strings, and also 3-component single cases which we buried down a deep hole. The reftex were laid out in a separate spread about halfway between the geophone spread and the well. This spread was rolled along at half the rate of the main spread, so that the 2 separate spreads converged as we reached the well. The reftex are 6-channel remote recording instruments, and they were programmed to be switched on for a few hours in the middle of each day, hopefully during the window when we were shooting. The reftex were hooked up to 3-component phones down a hole.
You're going to be on Western TV, Dean. TV? You'll be on Western TV.
And they were pre-programmed by Rick Blenkner and Alan Tanner from Wyoming with a plug-in portable computer. Dave Smythe, the leader of the Glasgow contingent, checks on the radio that everything is now laid out and just about ready to go, so we are ready to record. Everything is controlled by Chris Humphreys in the Wyoming doghouse. He is using a 96-channel MDS-10, and over in the Glasgow doghouse there are another 2 such systems, making a total of 288 channels.
And then somebody should be coming along behind to patch it back in. Right now we only have one person though, and I'm not sure how it'll work here, but I see they're out, the vibrator drivers are unplugging them. I think Andy will plug them in maybe after we get going here.
So my fault is short that tape, so I take confidential rewind right, 15 seconds.
So after all the various messages are passed up and down the line between the vibrators, the Wyoming doghouse and the Glasgow doghouse, David Abensur primes his systems and sits in radio silence, waiting for them to be started remotely by Chris.
Is that a test?
No.
That was it?
Science in action.
The beeping dialing code tones you might have heard are the signal to tell the vibrators to start vibrating and to initiate the 2 Glasgow MDS-10s over in the other doghouse.
How many sweeps are you doing?
8.
Is that the 3rd one?
This is in fact the 3rd one.
After a successful day's recording, the southerly spread of geophones and cable is lifted and moved to the north. And back at the ranch, Lee and David do some processing of the day's data to check that we are not simply collecting garbage. The QC processing was done mainly with Promax, and some of it was also done with Micromax.
Samples over the roof of that are in the wrong place. What do you mean, these zero? Oh, these are too low. Oh, clearly. They're not zero. No, but these are too low. They should be.
The final stage in moving the line on is to move the 2 doghouses up by 1.5 kilometres to their next position, followed by the line crew in their own vehicle. Of course, these scenes of sunny weather tend to give a rather idealistic view of everything running smoothly, which was far from being the case. We had many problems due to the weather, due to the underfunding of the British contingent, and to the economic situation in the former Soviet Union. For much of the survey, the field party had to go out every day in a Russian ex-army armoured personnel carrier, a very uncomfortable trip, sometimes taking as long as 2 hours in each direction. The weather was often fairly severe, with overnight frost down to about -30 centigrade, and it is certainly no fun laying geophones in these conditions. The terrain was a very severe problem, and getting the vibrators over some of the big hills was quite an undertaking. Per de Granis from Bergen heads off in the first vibrator, pulled and pushed by 2 bulldozers. And he seems to have made it to the top okay. Doyle Watts from Glasgow follows up in the second vibrator, but things seem a bit more difficult for him. His pad has jammed down here, and you can see him waving in his best Russian to tell the caterpillar driver to stop. The Bergen vibrators took quite a lot of punishment on this survey, as you can see, but eventually we got them all over that big hill. Another problem was getting generators to supply us with 220 volts AC round the clock.
The huge Russian generator that we have over here, you might want to just take a quick look at it. This generator here,
Apparently from a Russian Second World War submarine.
we really have no idea how much power that produces. But here we have our little generator. This produces 500 watts. The Russians are really impressed.
After a week or two we managed to get a steady and reliable supply of power at the field camp, but we couldn't run the power 24 hours a day out at the doghouses. So every morning we had the problem of unfreezing the equipment.
What, is that an American one?
Actually, Andy's wrong there, it's a Bosch German make. Planting the geophones in the 1 to 3 metres of rather soft snow was very difficult as well. Nick Boyd from Wyoming is trying to plant a horizontal component phone, vertical, using its little spirit level.
Yeah. It's not like real soil.
And of course aligned properly either north, south or east, west. Andy Olsen uses his long legs here to bury the vertical geophones deeper in the wet snow. Towing the vibrators through the deep snowdrifts often caused the towing cable to break. So again, the minutes and hours of each survey day ebbed away. Soon we were into May, and the snow began to melt. The sun played havoc with the geophone orientation. The carefully planted horizontal geophones simply tilted over and twisted around during the sunny daylight hours. It was futile trying to plant them in an accurate alignment, which was one reason for us resorting to the buried single cases. Meanwhile, operations were proceeding at the well. The hole is still at 12,261 metres depth, but while we were on the survey, a 2 kilometre length of drill string had been dropped down the hole. Here is some bent pipe that has been retrieved from the hole. As we move up the gallery with the drill bits and pipe lying there, we get a chance to look at the drill floor. I was able to go up with Mark Zarhin as my interpreter and stand on the viewing gallery on the drill floor. The drillers are preparing a fishing tool to go down to 10 kilometres depth to try and catch the lost drill string. The rotary table is used here for connecting together the various components, but for actual drilling, the whole 12 kilometres of drill string is not rotated. Instead, only the drill bit is turned by a turbine at the bottom, which is powered by the mud pressure. One of the drillers told us that they had some major advances in drilling technology, which the Swedes and Germans were interested in buying. But the communist bureaucracy had decided that if foreigners wanted it, then it must be too important, and therefore classified it as secret. So they never got permission to export their expertise and earn some valuable hard currency. David Guberman, the director of the deep well, now has severe financial problems making ends meet. He would like to turn the Kola well into an international experimental centre, where visitors, particularly from the West, could use the hole as a natural laboratory. The block and tackle, or hook, is capable of lifting 500 tons, and behind it you can see the stack of several hundred lengths of drill string, each 37 metres long. As that section goes down, we can see the wedges going in to clamp it and hold it hanging there. And up comes another section of pipe ready to be screwed on. Despite our problems out on the line, we eventually made it to the well after 2 months. Here comes the Glasgow doghouse to its final position, a few hundred metres southwest of the well. While the spread went to the west of the well, the vibrators would go to the east, or over on the right, so that we would get depth points right under the wellhead. And the convoy of vibrators comes over the last big hill, heading for the well. With no actual driving to do, the drivers, like Alan there, can afford to sit and read a book during the sweep. And Rick and Andy take a smoke break. The survey line pursued a slightly crooked path to the north, passing just west of the well. The vibrators were then able to go on the road running east of the well, and also along an east-west road 2 kilometres to the north of the well. This map has a 1 kilometre square grid and shows the green crosses of these additional vibrator positions, and the red wiggly line is the main 2-dimensional survey line. The grey area shows the 3-dimensional, 3-component coverage we obtained around the well. This is tied into the well by VSPs. Up on top of the well tower, we can look down on the Sputnik or satellite well in the little hut below, and north over the frozen lake to the end of the survey line about 2 kilometres to the north. Down below us to the south is the Wyoming doghouse, and just below the well, the Glasgow doghouse. Out there on the road are the vibrators, now working under their own steam. Back inside the well tower, we can look down on the stack of pipes, now depleted because most of them are down the hole. And here are the instruments the driller uses to get all his information. This is about a week after the preparation of the fishing tool, and they are now within 1 metre of catching the dropped drill pipe at 10 kilometres depth. The fishing tool is helically scanning around the side of the hole as it moves down slowly, a few centimetres an hour, until it locates the top of the lost string. This is the automatic pipe storage system. The Russians call these lengths of pipe candles, and you can see how flexible they are. There are 304 such candles, each 37 metres long, down the hole at the moment, and the stretch in the total drill string adds up to another 30 or 40 metres.
And this is the number of drilling candles. It's a size of resistance for equipment.
Drilling resistance or something like that, yeah.
Drilling. This one is the pressure of during the flushing.
Yes.
Flushing.
Mud pressure.
Какое давление?
Давление 20.
20.
20 атмосфер.
20 atmospheres.
Atmospheres, all right, yes, yes.
The big dial on the left is the hook weight, and you can see that there are 200 tons currently hanging on it.
So what is that, Sasha?
The weight of drilling equipment, which is in the
Which is now.
working now.
Ah, right.
The driller estimates that we are possibly within a few minutes of locating the lost drill string.
Может быть, к концу смены.
4 часа,
Да,
да?
к 4 часам.
We will know exactly whether the fishing was successful.
Если у нас
After 12
увеличится вес,
hours.
значит... Это 40, по-моему. Опа!
Пошло давление.
And after a short time, he notes some movement on his instruments, apparently a pressure change. The drill string is slowly withdrawn a few metres.
Михалыч, на 15 литров переходи, но не менее 20, чтобы было.
And he informs the boss by telephone what is happening. And yes, it appears that they have caught the drill string, because the hook weight has now gone up from 200 tons to 280 tons. The The problems at the well meant that we were unable to do the full VSP that we had hoped, but in the meantime we tested the new Russian tool in the Sputnik hole, situated a couple of 100 metres north of the main well. This new Russian tool performed remarkably well. It digitises downhole onto a 3-conductor cable, and we were eventually able to use it down to a depth of 6 kilometres in the main well. The full instrument is a 3-level tool, the levels being 25 metres apart. For our survey, it was recorded on the Wyoming doghouse by Chris Humphreys and our Russian colleague Mark Zarhin.